Welcome to the Hardest Questions Challenge. This is a foundation question from 2017, paper 3. So you've got a regular polygon, regular 12-sided polygon there, and you can see part of it. BC is one of the sides, and either side of that BC length is two squares. Okay, and you're shown length AB and length CD. So we have to prove that the polygon that fits, polygon P that fits in here is a hexagon, basically. It's a regular polygon. So we're trying to prove that that polygon that fits in there, so in other words, it would end up looking something like that, that is indeed a hexagon. In other words, it has 6 sides. I'm going to use a method of working with the interior angles all the way through, so for continuity. So the interior angles, remember, are these things inside the polygon. Okay, so these are the interior angles of the 12-sided polygon. Okay, a dodecagon. So we would need to work out one of those. We know the square has an interior angle of 90 degrees. So about the point P, we could then figure out that actually, if we could work out this angle here, and at C it would be the same because it's allegedly a regular polygon, so we'll assume that it's the same. So we need to prove that this angle here is the same as it would be on a regular hexagon. Okay, so 12-sided polygon. I can break or dissect a 12-sided polygon into 10 separate triangles. In other words, that's the n-2 method. So in other words, if you've got n sides, you will end up with n-2 triangles. Okay, each triangle consists of interior angles totaling 180 degrees. So if it's 12 minus 2, that's 10 lots of 180, which is 1,800 degrees. So around that shape, the 12-sided polygon, you will have a total of interior angles coming to 1,800. So each one of those would end up being 1,800 divided by 12. So one interior angle would be 1,800 divided by 12. It's a calculator paper, so let's just pop those numbers in. 1,800 divided by 12 is 150 degrees. So let's put this in a different color. So this angle here is 150. This angle here within the square is 90. So about point B, we have the following. We have 150 degrees here. We have 90 degrees here. And therefore we can work out from the angles at a point, total 360. So we would work out that one of these interior angles of the polygon P, so let's call this X, X is equal to 360 minus the sum of 150 plus 90. So again, on the calculator, 360 minus, open brackets, 150 plus 90, close bracket, that equals 120. Okay, so we have to prove that that is the interior angle of a regular hexagon. Well, here's how you do that. Regular hexagon. Regular hexagon has 6 sides. So again, going with the working out the size of an interior angle, a regular hexagon having 6 sides can be dissected into n-2 triangles. In other words, 6 minus 2 lots of 180. That therefore is 4 lots of 180. So 4 lots of 180 on the calculator is 4 times 180 is 720. So one of those angles yeah, the total of all of those interiors, okay, is 720. So one interior angle of your regular hexagon will be of size 720 divided by 6, which quickly on the calculator proves to be the same as the angle X. Therefore, you have shown quite clearly that the polygon P, having this interior angle of 120, will be a regular hexagon.